Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss some applications when an object is thrown from the top of the tower and it is dropped downward direction and it is freely falling. So based on that concept we are going to discuss one application. So what is the application means? Three bodies are projected from the towers. So three bodies are projected from the towers of same height. So these are the three towers of same height. Same height is h has shown. First one is projected vertically up with velocity u. So first one is projected vertically up with velocity u. With the velocity u. The second one is thrown down vertically with the same velocity. So this is the second tower of same height. The object is thrown down with the same velocity. Same velocity means u equals to u itself. And the last one, third one is dropped freely. Freely falling body means the velocity will becomes 0. If T1, T2 and T3 are the time taken by them to reach the ground. So first object is projected vertically up from the top of the tower with velocity u, and second one is thrown down vertically with same velocity u equals to u, and third one is thrown freely from the tower, freely falling body from the tower, that is u equals to 0. As you all know that for a freely falling body initial velocity will be 0, and the three bodies to reach the ground, the time taken is first body is T1, second body is T2 and third body is T3. So the time taken by the first, second and third body to reach the grounds are T1, T2 and T3. Now based on this concept we are going to find some terms that are velocity of projection is. So we are projecting which velocity? U velocity. Now we are going to find the value of u. You cannot find the u value for the third body because we are throwing freely from the top of the tower. So u equals to 0. So we can, by using these two, first one and second one, we can find the velocity of projection. Why velocity of projection can be found for only first and second one? Because we are projecting vertically up and throwing downward with initial velocity u itself. So by using these first and second, we are going to find the velocity of projection. But there is no velocity of projection for the last body because it is freely falling body, u equals to 0. So by using first two, we are going to calculate the velocity of projection, that is u. So to find the value of u, I am considering T1 is the time taken by the body to reach the ground. First body to reach the ground is time T1, and T2 is the time taken by the second body to reach the ground. As you all know that what is the first body? A body which is projected vertically up from the top of the tower, means it is upward motion, that is time of ascent. After reaching the maximum height, it falls freely and reaches the ground, that is time of descent. Means the time taken by the first body will be equal to the time of flight. But the time taken by the second body, we don't know, that is T2. So the extra time taken by the first body compared to second body. But why? Because here the object is projected vertically upward from the top of the tower, and after reaching the maximum height it reaches the ground. This can be taken as time of flight, I said. So this is the time taken by the first body. When compared to second body, the object which is vertically thrown downward with same velocity, but we are not projecting vertically up here. Here is the, compared to these two, this is the extra time taken by the body, that is time of ascent. So clearly the extra time taken by the first body, that is T1 minus T2. When you remove T1 minus T2, you will get the extra time, that is equal to time taken by the first body, that is time of flight of first body. So 2u by g equals to t1 minus t2. Why I am taking time of flight here? Extra time taken by the first body. Why? Because the time taken by the first body is time of flight. So extra time taken by the first body t1 minus t2 is equal to time of flight. Okay, 2u by g equals to t1 minus t2. So what you want here? U. So send these terms here. 2u equals to g into t1 minus t2 and u equals to 1 by 2 g t1 minus t2. So this is the velocity of projection. Velocity of projection is half g into t1 minus t2. t1 minus t2. Why I am taking t1 minus t2? Why I am taking t1 minus t2 here means compared to second time, the first time will take an extra time because it is following time of flight. So t1 minus t2 equals to time of flight. So based on this concept, we found the velocity of projection, that is u equals to half g into t1 minus t2. Now we are going to find the height of the tower. So I said each of them is projected from the same height. So we are going to find the height of the tower. So we know that so here the object is projected vertically up. The time taken is t1 and thrown downward is t2 and freely falling is t3. So here we are going to find the height of the tower. We know that for a vertically projected upward body, s equals to or h equals to ut plus half at square. So upward projected body means a equals to minus g, h equals to ut minus half gt square. What we have u here? We got u as half g into t1 minus t2. Substitute here, h equals to u equals to half g into t1 minus t2. Half g into t1 minus t2 into t1. Why I am taking t1 here? Why? Because vertically projected up body only done for the first body. So I am taking as time t1. So what I am wrote here, we know that for vertically projected upward body, here only vertically projected upward body will be for first body, that is time t1. So I am taking as time t1 here minus half g t1 square. So multiply this, half g t1 square minus half g t1 t2 minus half g t1 square. These two will be cancelled. H equals to half g t1 t2. So this is the height of the tower which is projected vertically up. So h equals to half g t1 t2. So just remember that why I am taking t1 here, because we are projecting vertically up only for the first body of time t1. So I am taking the time as t1. So we got it as height of the tower is h equals to half g t1 t2. Okay. Now time taken free fall in the third case. So we are going to find the what they said to find free fall time taken in the third case is t3 equals to t free or t3. So we can taken time as t3 here, no t3. We are going to find a time for a freely falling body. As you all know that for freely falling body, u equals to 0, a equals to z, s equals to h here. So substitute in the equation, that is s equals to ut plus half at square. At square. S, what is s here? S is h, u is 0 plus half g t 3 square. 3, why I am taking 3 here, time taken for the third body, no? So you can take as t free, freely falling. So you want t here, so make it as subject, h equals to half g t3 square. So send these terms here, 2h equals to g t3 square, that equals to t3 square equals to 2h by g. 3 represents time taken by the third body, that is freely falling body. If you send square here, square to right hand side, it will become square root. Square root. T3 equals to under root 2h by g. We have h equals to half g t1 t2. Substitute this h value here. So t3 equals to under root of 2 h is half g t1 t2 by g. 2 will be cancelled, g will be cancelled. So t3 equals to under root of t1 t2. So the time taken by the freely falling body is equal to under root of t1 t2. So under root of t1 t2. So this is the time taken by the freely falling body in case of 3 cases. So now we are going to discuss one more application, that a same body is projected at 2 different times. So from the ground, a body projected vertically upwards from the ground. A body is projected vertically upward from the ground is at the same height h. Same height h from the ground at 2 instants of time t1 and t2, both being measured from the instance of projection. Now, so I took an object, I projected vertically up with an height h. The time taken for the first time is t1, and next the same body is projected with the same height and time noted as t2. Based on this concept, I found some terms which is similar to these terms that we have discussed, that to one body is projected vertically upward from the top of the tower and thrown downward and freely falling. The equations will be little similar like that only. Same bodies are projected from the ground with same heights but different times. After reaching the maximum height, it reaches the ground. The time taken is t1, and same body with different timing. We are considering different timing, that is t2, projected with same height. After reaching the maximum height, it reaches the ground with the time t2. So the height can be written as half g t1 t2. So same as like this only, half g t1 t2. So two different times but with same height na, h equals to half g t1 t2, and u will be half g t1 plus t2. Why I am taking t1 plus t2? They are projected with same heights in same positions but the time taken is different. So half g into t1 plus t2, and maximum height, after reaching the maximum height it reaches the ground. So maximum height, what will be the maximum height with the total time? This is the total time. I said the relationship between maximum height and time of flight is h maximum equals to 1 by 8 gt square. I am taking total time here. Why I am taking total time here? The body projected upward. After reaching the maximum height, it reaches the ground with time t1, and this will be the time t2. Same body. So half 1 by 8 g t square. The t time will be t1 plus t2 whole square. I wrote the same body now in form of combination with times I wrote here. A body dropped from the height h, time taken, that is under root t1 t2 to reach the ground. Same as this. Under root t1 t2. Freely falling now to reach ground after reaching the maximum height, u will become 0. So under root t1 t2. That will be t free. T free means time taken by the freely falling body under root t1 t2. Why I am taking plus here now? Plus here because same body is projecting with from the ground of same heights, but the time taken is t1 t2. So combination, in the form of combination of times I wrote this. So same body with two different times from the ground of same height means you have to use these formulas, that is plus. If I took a body which is projected vertically upward from the top of the tower and thrown with same velocity downward direction means I should take it as minus here, minus. So this is the two important applications. So if you have any doubts, please comment me in next video. We are going to discuss the problems based on vertical motion. So please like, share and subscribe my channel. Thank you.